Let's take a look at some additional valid patterns, valid forms of argument. So far, we've been looking at patterns that are in what's called propositional logic. The idea is that sentences or propositions are the components, and there are some logical connectives, if then, either or, that connect different sentences or propositions, and that's what makes the argument work. That's what makes the logic work, makes the good connection between the premises and the conclusion. Now we're going to turn to some forms of argument where it's actually the structure of the sentences or the propositions themselves that make them work. It's something called predicate logic. The idea being a sentence has a subject and a predicate, and what makes these inferences work is the predicates that are involved, and it's really dealing with the words all and some, the logical connectives. But you'll see after we see the patterns what this is all about. Well, if you take a look at the inference on the right, the propositional logic pattern that we're talking about, modus ponens, one that we've seen: if P then Q, P therefore Q. If Socrates is a man, then Socrates is mortal. Socrates is a man, therefore Socrates is mortal. Well, if you look at the pattern of argument on the left, you're going to see similarities. But this one is slightly different. It says all A's are B's, X is an A, therefore X is a B. All men are mortal. Socrates is a man, therefore Socrates is mortal. If we look at the two arguments in English, we see they are really very similar arguments, both of which are valid. That is, there's a good connection between the premises and the conclusion. On the one on the right, it's the if-then, connecting the different propositions or sentences that make the inference work. The one on the left, it's all is. And notice, in the if-then, the way modus ponens works is we're kind of going from left to right, and I'll explain to you what I mean. If we start with if P then Q, then we affirm the antecedent P, and it tells you we can move to the right the way we write in English and infer Q. Well, look at the way it works in the predicate pattern. All A's are B's. X is an A, something is the one on the left, therefore something is the one on the right. This is going to become important when we look at the next one. Now remember, the next pattern of inference we saw in propositional logic was modus tollens, sometimes called denying the consequent. If P then Q, not P, therefore not Q. If lima beans are a dessert, then they're sweet. Lima beans are not sweet, therefore lima beans are not a dessert. Now take a look at the pattern over on the right. All A's are B's, X is not a B, therefore X is not an A. Similar pattern. All desserts are sweet, lima beans are not sweet, therefore lima beans are not a dessert. Very similar arguments, very similar patterns, and they're both valid because they kind of work the same way. And notice, I'm going to tell you, so you remember this, now we're working in the negative direction. If we look at that second premise, we have nots in both cases. So we're working from, normally we write from left to right. Now we're working from right to left. And if you're like me and you sometimes don't know your left from your right, you're going to have to think about this carefully when I say it, because when I'm driving along, I sometimes am told to make a left turn and I make a right turn, and I guess it was the other left that I used, but the idea is left to right, where you start writing, to right where you end the sentence. But now we're going into the not direction, into the other direction. If P then Q, not the second one, therefore we can infer not P. Same thing with the all A's or B's. X is not a B. X is not a second one, but it's a not, so we're going in the negative direction. Therefore, X is not an A. Now, the reason I'm making this whole big deal about which direction we're going is if we swap in both modus ponens, modus tollens, and the two forms. By the way, the predicate forms don't have names. You're just going to have to remember the form of the argument. But if we swap the conclusion in the second premise, that is, go to modus ponens, if we say if P then Q, if our second premise were Q, we could not infer. It's a fallacy to infer P. So it only goes in one direction, the positive direction. On the modus tollens, the inference only works in the negative direction. The going the other way in both cases is a fallacy, is a bad inference. And the same thing holds true. All A's are B's, X is an A, X is a B, going in the positive direction. If we're going in the negative direction, that is, if that second premise was the conclusion, we can infer anything. And if you're a little confused about it, stop right now and sit down and try to write an argument it's going in the other direction, and just write the first premise and the second premise and tell me what you can conclude, and you should realize that it's not going to work. But okay, we see the analogy between these two kinds of inferences, between the propositional inferences and the predicate inferences. Let's look at the final one we wanted to take a look at with regard to if-then's hypothetical syllogism. If P then Q, if Q then P, therefore if P then, I'm not sure I said that right, if P then Q, if Q then R, therefore if P then R. If that is a dog, then it is a mammal. If it's a mammal, then it's an animal. Therefore, if it's a dog, it is an animal. Now, some of you might say, gee, I understand that this is trivial. Yeah, these are obvious. We're going to come across arguments that use inferences like this that aren't so obvious. I'm giving you the obvious case so you understand that it's valid. But that was hypothetical syllogism. And notice in predicate logic, with alls, we have something similar. All A's are B's, all B's are C's, therefore all A's are C's. So here are some additional patterns, predicate patterns that work. As I said, we're not going to exhaust all the possible valid patterns because there are really a lot of them and too many to remember.